Hello, hi. My name is Jim Heffron. This is the second of my videos on Calculus 1. So already a detour. So I think many people in a Calculus 1 class are in their first semester of their first year, so it's a good place to go over some sort of very first principles of how to study college mathematics. So that we're going to do that today. Okay, let me see. Let me get to the page. There we go. So in high school, your instructor was in charge of whether you learned the material or not. And maybe, for example, if you missed a quiz, the instructor would come up to you and say, you missed a quiz yesterday, Jeremy. You need to come after class to make it up. And you worked it out between the two. But in college, that's just not so. In college, it's on you. If you miss something, then it's up to you to somehow figure it out. I sometimes have people come up to me after class and say, I missed Monday, and I said, well, it's up to you to get the notes from somebody. It's just a question of growing up, sort of being a more responsible individual. I hope this presentation helps you to step up to some extent. I'm going to address a Calculus 1 student, although the advice applies really to any math course in the first couple of years. And I'm going to be brief and prescriptive. Prescriptive means I'm just going to say, do this, do that, do that. If you want to know more about kind of the underlying principles, and they're all very interesting, if you want to know more about them, I have two sources that I can recommend. This Veritasium video, he does a good job on everything that I know of, and there he does a good job in this video in particular. And then the Learning Scientists is a great website to visit, and they also have a podcast, and you could do a lot worse than to listen to, say, the first half dozen episodes in the podcast. You can listen to it for example, in the car, maybe in the car driving up to college, kind of thing, and you'll learn a lot. You'll learn a lot about the principles behind what it is I'm going to suggest to you. Okay, but here's my suggestion: get a schedule book. I like a paper book. I know sometimes people try to do it on their phone. I really think a paper book is better. But anyway, get a schedule book. Write down all your assignments, the exam dates, etc., the moment you get them. So as the instructor is saying, there will be an exam on Chapter 1 on Friday, October 13th. You're writing down, you've got the Friday, October 13th thing, and you're writing down exam calculus, kind of thing, Chapter 1. It's heartbreaking. But every semester I have people who walk into, when I'm handing out the exam papers, and you can see from the expression on their face. Last semester I had a person, she had forgot, she forgot. And, I don't know what to say. You need an assignment book. She ended up not doing very well in the class. But so you need an assignment book. You got to write all that stuff down. You're not going to remember it. You got to write it all down. Okay. And speaking of study plan, you should study 2 hours outside of class for every hour inside class. You hear that advice a lot, and the reason is because it's very good advice. Of course, sometimes plans change. I mean, sometimes you say, well, I was supposed to do math on Thursday, but I had to go to the registrar's office and straighten out that thing with my physics lab. I perfectly understand. But nonetheless, you'll quickly work out a pattern. Say I'm studying math on Monday, Thursday, and Saturday. And a good pattern takes you a long way. If you'll wake up on Thursday and say, well, today's a math day, and also I'm doing that French paper. The schedule book will help you calibrate your effort across classes, because you might say, I got that history exam next week. I'm going to have to borrow some time from French and economics in order to study for history. So you'll be able to have a sort of higher level overview of what you're doing. Every class needs its own notebook. Please use it for both class notes and for homeworks. Sometimes I have people come to my office hours and they take something out of their backpack, and I say something because it's not really clear what it is. It's a pile of papers. Sometimes they're writing on the back of old papers, and when you look in there and it says, like, when you go to the grocery store, don't forget to buy coffee. There's a mixture of economics and anyway, you need a notebook. Date each day's work. Start it on a fresh sheet so you can find it later. Use a pencil. This is math class. Use a pencil. If something gives you trouble, then put a big asterisk in the margin. I know when somebody comes to office hours and I say to them, how you doing? What's giving you trouble? And they say, well, I had some problem with Monday's homework, and they take out their notebook and it's reasonably written. It says math on the front, and there's a big asterisk next to number 15. I say to myself, well, this person is going to leave office hours knowing the answer to the question. Pomodoro. You need a timer. Here's my timer. I bought it at a hardware store for not much money, and it's very well used. Pomodoro is the person who invented Pomodoro. He was an Italian person, and he had one of those kitchen timers, the kind that you turn it and tick, 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 and it was in the shape of a tomato. And tomato is the Italian word for Pomodoro. Pomodoro is the Italian word for tomato. So the idea is it's a discipline that keeps you in line. You work 25 minutes without interruption, and then you take a break for 5 minutes. So, maybe you take a break, you go get a drink of water, go to the bathroom, just stretch your back. That's all. But 25 minutes without interruption, then a break for 5 minutes, then 25 minutes, etc. It's a discipline that keeps you on track, that makes sure you get the work done that you need to get done. And man, I find it very helpful. No phone. No phone. Just to be an old guy, I have to say no phone. Please, we all have phones. Here's my phone. We all have phones. We all have trouble putting them down. But if you're in the middle of your Pomodoro session and the little thing makes a noise, you don't even pick it up to look. Who's calling me? Is that Kayla? No, don't even look. The person who's calling you or texting you will be just fine if you call them back when the Pomodoro session is over 10 minutes from now. In addition to no phone, part of that is no listening to music. When I go to the library, I see people with the things in their ears. My younger son had the things in his ears, and he would say to me, "Oh no, I need this music to calm me down, to make sure that my mind is set. I'm only listening to the music a little bit." And I'd say, "Alan, you're just making yourself 20% dumber. Don't do that. You can't afford it. None of us can afford that. Don't do it. Don't listen to me. Listen to music later. Great. I love music. Listen to it later." Okay. So no phone. No music. This presentation has 3 slides, and this is the middle slide. And I want to say something in the middle slide that doesn't make any sense. You're gonna hear it, and you're gonna say, "Nah, how does that work?" That's why I have a whole slide devoted to it, because it's a key point, but also because you're gonna say to me, "I don't see that at first glance." No, that's right. Okay, so people learn by actively engaging with the material. If you're just watching it, if you're watching some videos on YouTube, you're probably not learning much. It looks easy, but you probably didn't learn how to do it. For instance, if your instructor goes over homework questions, then you'll get more out of it if you've already tried the question. If you watch the instructor doing it, you're like, yeah, it looks easy. If you tried it yourself and you got stuck at a stage and then you watch the instructor do it, you'll say to yourself, "Oh yeah, I remember. I didn't know what to do with the sign here." And then the instructor does it and you go, "Oh, I see." When you square both sides, that takes care of the sign. That makes all the difference in the world. Research and learning is the part that a person should say doesn't make sense. Research and learning has proven that the brain doesn't work like a computer. You don't just put something in a memory cell and then it's available when you need it. Sometimes when you see somebody studying and they're really trying to study hard, they're like X squared. That's not how you learn. Instead, evolution's twisting path has built brains so that you don't make memories firm by putting them in there. You make memories firm by taking them out. That is to say, memories are made solid by repeatedly retrieving them from long-term storage. It doesn't make any sense. I understand that. Did you ever sprain your ankle and you go to the doctor and they show you, they say, have a model of the ankle, what you've got going here, and you're looking at it and you're saying, that doesn't make any sense. There's something wrapping around inside that other thing. Who would design such a thing? And the answer is nobody designed it. Evolution made it. Well, it's the same thing with your brain. That's just the way it worked out. Memories are made solid by repeatedly retrieving them. Now, if you're drilling only uses short-term storage. If you're doing flashcards, they're not foolish, but they only use short-term storage. So drilling alone is not enough. In addition to mastering new material, you also have to practice fetching prior things. So if you're learning new material and you're doing question 1, question 3, question 5, question 7, that's great. You're doing it right. That's fine. But if you're trying to retain the old stuff, you got to practice fetching it from long-term storage. Okay, so self-test. For a Pomodoro session, you make up a quiz of 5 questions and use questions where you can find the answer so that you get instant and correct feedback, because if you got the wrong answer and you went on thinking it was right, you didn't learn anything. Or worse, you learned the wrong thing. Of course, these self-tests, you should work on weaknesses. The feedback will reveal what it is you don't know. Maybe, for example, you say to yourself, when I do these, the trigonometry ones don't really bother me, but the logarithm ones keep giving me trouble. I'd better go back and do a couple more logarithms. Okay, that's right. That you're doing it the right way then. So you want to work mostly on the things that give you trouble, not so much on what you already get. So have you seen a pattern here? This is starting to sound a little bit like work. And you should do what's called spaced repetition. Of the 5 questions in your self-test, 1 or 2 should cover things from last week or last month. The others cover new material. That's fine. You're trying to learn new stuff. That's great. But 1 or 2 should cover things from last week or last month. So you're retrieving it from long-term storage. So you come to that question in your self-test and you go, oh yeah, what am I supposed to do for implicit differentiation? I'm supposed to do what now? So that's that where you're going, oh wait, how do you do that? That's a little harder than just doing the present days, but it's right. And that little harder is a bit of a lesson here. If you find that your studying is a bit of an effort, not murder, you're not going around saying, oh, I must be a dope because I'm not getting this. Not murder, but not super easy either, then you're probably doing it about right. Struggling with new ideas, experienced math teachers know that people have to struggle with new ideas. It's a key part of mastering them in math. I don't know about other fields, but in math, it's a key part. It's necessary in order to master things that you have struggled with them. That's part of what learning involves. Okay, so example. Again, a person coming from high school has probably been guided through most of this by their instructors in high school, but in college, it's on you. So you can find, let's say, Friday, your first week of class, maybe you have me for calculus, and I covered section 2.3, and I assigned homework 9 to 23 odd. So now here it is Saturday morning. You're excited about this new adventure of college. You put your stuff in your backpack. You go off to the library. You find a quiet spot. You spread out your papers. Got your pencil, your textbook, etc. And now there's a quiet moment, and you say to yourself, what is it that I'm actually doing? Okay. And the answer is 2 hours outside of class means 4 Pomodoros. For the first Pomodoro, maybe you go over the class notes. You don't just recite the definitions and theorems. That's not active. Instead, go through the material actively. You might, for example, come to one of the examples that your instructor did in class, and you say, okay, he wants me to say x squared equals 5y squared plus 7. All right, so you write down x squared equals 5y squared plus 7, and you say, let's see, what do I need to do now? And you go, at some point you get stuck, so you go, oh, that's right, he moved things to the other side of the equation. So you're being active. You're working with the material. Okay, so that's 1 Pomodoro, 5 minutes, you get up, get a drink of water, you come back, 3 more Pomodoros. You could do them problems. For instance, during your first session, maybe you might pick for review, you might go section 1.7 in the book. I picked that out of the air, I just made it up. In that section, you might pick homework 11 and 23. I picked them because they're odd and the answers are in the back of the book, so I'll know whether I got them right. And for the remaining 3 self-test questions, I'm going to section 2.3 because that's what we covered in class on Friday. Example 9 looks good, okay. And then the instructors told me to do 9 to 23 odd, so maybe I'll do 9 and 11. Okay, go. Start the timer. Don't just look at the questions and look at the answer and say, oh yeah, I could do that. No. You have to actually do it. In particular, for the review, for section 1.4, make sure that you're actually doing those problems because it's in the details that success or failure. You're looking at it and saying, that's easy. No, it's not easy. Can you imagine a person trying to learn to play violin and they said, well, I just went and looked at the violin and it all looked pretty easy. You'd laugh. You'd say, that's dopey. Well, it's dopey here too. You need to actually do the problems. If you get stuck on one, now don't spend 20 minutes walking around going, oh my God, I'm an idiot. No, spend a couple minutes, give it a fair try, and then say, okay, I'll have a look in the back. Oh, that's right. You got to remember to divide both sides by the square root of, that's fine. Or maybe it's one of these ones where you say to yourself, I didn't get that one. I'll put a big asterisk next to it in my notebook. Great. But the point is you have to actually try it, and you have to give it a couple minutes. All right, so now here, you've done 4 Pomodoros. It's the end of the day, and it's a good feeling. I mean, you put stuff back in your backpack and you head out for lunch, and you made progress. I mean, you'll feel it. You'll say to yourself, yeah, I got some work done. I now understand some things that I didn't understand when I sat down. And maybe you'll have a question or two to ask in the next class. Now, very important. People sometimes say, I didn't want to ask a question because I didn't want to seem to be a dope. No, the dopes are not asking the questions. The people who are asking the questions are the ones who tried the homework and got stuck halfway through. Those are the people who are going to do well in the class. So you want to be one of them. This is how people learn. People don't learn by looking at it and saying, I'm a genius, so I see that. That's not right. People learn iteratively. At first, they understand maybe 80%, and then maybe they go home and study it for a while, and now they got 90%, and then they ask a question in class, and now they understand it 95%. That's how people learn. That's how progress gets made. Okay, very good. So when we come back next time, next video, I'm going to actually do some actual math. So that'll be fun.